Well, guys, I kind of got sidetracked. Last we talked about was the oil pump and the apron, and I got mighty excited about that, and I'm still pretty excited about that. But man, I just got the urge to turn some metal, and I got a project I can do. Um, I got my old it's the control rod to activate the crossfeed clutch, powered crossfeed, and this is off of the machine. Um, and this from here up is supposed to be at least 100. From here up, it's supposed to be at least 100 thousandths greater. Um, it should fit in here a little better. Um, this thing took such abuse while I was trying to get the crossfeed unfrozen, working, while it was all installed in the machine. And I had vice grip marks all over this, and actually bent this shaft quite a bit, and in getting it prepared to go back in, I ended up turning this down a bit and did a little straightening here and got it running relatively true, and there's videos on that. So I got a piece of material. Let's stick it on the mini lathe and see what we can do. Now, typically you can't machine anything more than 6.5 inches on the mini lathe, and this is right at 6.5 inches. So it also well, let's see how it goes. So hope you enjoy this little sidetrack project. After this, we'll get back on the oil pump. All right, guys, enjoy. Okay, I doubt if you're going to be able to see this very good, but I have numbers written down here, all my measurements. So the majority of this shaft is this is 340 thousandths. Yeah, I need this wide part down here, which is 877 thousandths is my largest diameter. And I can do this on the mini lathe as long as I can work this up into the body of the headstock, through the chuck into the spindle. Problem is the piece of stock I'm using here, I don't have the clearance. So I make the clearance. I can take quite a bit of meat off of that. And it doesn't have to be true. In other words, it's not going to be supported, because I can come back later and machine that into the final dimensions that that's supposed to be. I just need to get this diameter down, reduced enough to fit inside the spindle so that I can do the work down here. So I recently learned a little trick on the mini lathe to get a little distance, a little extra length. And if you can see something doesn't quite look right with the tool holder, it's because I turned it around. And I think that's a brilliant idea. I'm going to steal it. So as soon as I get this turned down, maybe only to here, well, I'll probably take it on down. As long as I can get this turned down to where it'll work in the spindle, I can I can take it out, shove it into the spindle, and start working on this end over here, the larger diameter end. So yeah, and we'll do the final. We'll all my and we'll leave everything. Let me see if we can get this to light up. I'm going to leave everything like 100 thousandths large, and when I do the finish, if I'm able, I don't think I'm going to be able to turn on centers. If the final piece is not too long, I'm going to do all the final machining turning on centers. Although I don't think it's that critical. I think this is going to be critical here, that those threads are square with this face, and that won't be a problem. All the rest of this will be fine, because this is the piece that I have, and it's, you know, I'm 50 thousandths, 100 thousandths shy of what this should be here. Now, this is probably this 435 thousandths now. It needs to be 435 thousandths. It's actually 100 thousandths shy of what it should be. This part here should be 435, and then it goes down to 345 all the way down to here. And then there's I need to get this gap, that measurement down. And then I got a 1/2 inch of 5/8 16 threads, and then I have 140 thousandths relief, and then I have this the end piece, the heel, which is 184 thousandths thick, 877 in diameter. So yeah, I thought this was a brilliant idea. Okay, I'm pretty sure I'm not going to be able to handle this. Probably running about 300 RPMs. Need to take this down to if I can get a 1/2 inch, that would be good. Gotta watch my clearance over here. Glad I happened to glance over there. Moving that tool holder has definitely changed. Okay, this will be my final pass, and all we're doing is reducing this diameter enough so that I can get it feeding into the headstock. The material is too long for this lathe. And really not taking anything off right now. So let's just call that done. So let me grab a piece of paper towel. The first cuts that you saw were pretty reasonable. It got very chattery after that, as you can see here. But that's all, that's fine. That's all going to be machined away. I just need to get that into the machine. So I can work on this end. And I'm going to get this faced off, and I'm going to drill a center and support that. Although it's not that much stick out, really. It's about borderline. So I'm going to turn my tool around now. Okay, we got a dead center there. Let's see what I'm looking for. I'm going to zero my poor man's DRO. And I have 892. What do I need? I need 877. So 892, 77. Let's try 20 thousandths. I don't think any of these dimensions are going to be real critical. Going to go about 200 or 300 RPMs, if that. Probably 100 RPMs. Spring pass. Okay, next I'm going to take a parting blade and take that down to my next dimension. I should go get the actual part. I need to take it down to about 400 thousandths. This is where you need left-handed tools. Well, that doesn't look square. If it looks square, it is square. Should be checking this for height. Although it seems to be cutting just fine. Say about parting is to keep the tool moving, and I'll tell you that's especially true. That's especially true with the mini lathe. Okay, I switched up parting blades. I went from a 1/16 to a 3/32. So let's see. See the difference in those. And we're not done with that cut yet. But what I need to do now is I need to start back here, and I need to take this down to my thread dimension, which I think is a 1/2 inch. And then from there we'll go down to 345, and this will all be 345 till we get to the end. Let's see what the camera's actually pointing at. So now I need to start out here and come down to, I think, a 1/2 inch for my threads. And then after the threads, the dimension's going to go down to 345 thousandths, and it'll be 345 thousandths for 3.7 inches. And then it's going to go down to up, and then it's going to go back up to 435. So we're going to take this down to the 1/2 inch. Actually, I think it's 5/8. And then we're going to come down here to 345 thousandths, and that's for 3.700 inches, and then it's going to jump up in size to 435 thousandths, and that's for 1.755 inches long. And then there's going to be a tapered hole there for a tapered pin. I think it's a number 4 tapered pin, but I don't know. I just wrote down number 4 just to have something to write down. So let me figure out how I'm going to reduce all this down to nothing, and then back up to 5/8. And okay, we're back after much machining. See the chips we get on ball hair. We're back after much manipulating of the parts. Okay, we're at getting close to the final. What I'm doing right now is here's my other clutch, same deal. So this has got this shoulder here and this reduced dimension here. So we got this marked for the larger dimension, which is going through the front of the apron and the star knob. So what I'm able to do here with the length is machine this down to the chuck, to the diameter that I want, and then I need to flip the material around and cut from the other side to meet this. And I think it's only about an inch, but I can't bring this out any further because of this end. So here I need to start paying attention, I guess. And I'm turning at maybe 200 RPMs, if that. Carbide insert. And okay, we're going to call it a day here. Here's my part. We got 4 features. We got this diameter here, and then we got this. See, the original one, I had machined that heavier diameter off. Just cleaning it up, repairing it from all the damage I did to it while I was trying to get this thing unlocked when it was still on the machine. So what we have left to do is cut the threads here. It's 16 threads per inch. It's 5/8. The best I can tell from the example here. I need to drill a hole, tapered hole, and I have a I believe this is a number 1. Yes, I have a number 1 tapered reamer, and I have a number 3. And one's a little loose, and 3 is a little too big. So I'm thinking I'm going to need a number 2 tapered reamer and a drill, which is the smaller diameter of the reamer, to get it started. And then cut the threads. I got my change gears for the mini lathe. I got my threading tool. So this will get mounted like this, and I will thread out here. No. Yes. Yes. So I'll be threading from here toward the chuck. I'm going to do some threads on a test piece first to make sure that I'm correct about the diameter. And that's pretty much it. I'm pretty excited to be replacing this piece. As you can see, this is like, you know, throwing a hot dog down a hallway. So this one fits much better. Not tight, but it fits much better. Oh, maybe 10 thousandths. Actually, that's what it is when I measured. You know, the difference between my boss here and this boss is 10 thousandths. That's it. I made a little drawing of my project to start with. I should have used Fusion. It would have been a good exercise for me. But basically, laid this on my copier and copied the part and then wrote my dimensions in. And yeah, just a little trick I picked up from somebody on YouTube. Okay, guys. Thanks for watching. Thanks for subscribing. Tell a buddy, bring a friend. And we want to welcome a new viewer, a new subscriber, and that would be EC Workshop. And EC Workshop is very cool. Now there's another new guy out there. This guy's not new by any means. He's known as Daryl, the other Daryl the Scraper. That's enough handles for one man. But let me try to find him real quick to make sure we know exactly how to find him. He, by trade, has been a machinery repairman. He's the guy they send out when you can't get your machine to do anything at all. The word is that he is tops in his field. When he was out there practicing it. So he has decided to do a YouTube channel.
So there's the turret tool plate.
And he's here he's working on a Hardridge turret rebuild. Goes into some pretty good detail. The name of the channel is Daryl Smith. Last night he had 52 subscribers. I suspect this will be one of the fastest growing channels out there. The man is very knowledgeable, and he's taking CNC machines apart and showing you how he does it and why he does it and what needs to be done to make things right. What a great asset. I'm just so glad that he's sharing his knowledge, because well, why do I say that? What proof do I have that he's also knowledgeable? But, hi, my name is Steve. He says he's the greatest. He says he was in the shop and they had serviceman after serviceman come in trying to fix this machine. And Daryl Smith came out and got the thing up and going in no time. All right, that's it, guys. Check out Daryl Smith and give him a sub. Let's make this. Let's let the YouTube community know that information is out there. All right.